This video will show the daily procedures and protocols for an experimental setup using the 114P blind sac pressure myograph. We will go through the dissection and mounting of a small vessel, as well as setting up the chamber for the experiment, running pressure steps, and a brief agonist response to contractile and relaxation agonists. For this video, we will be using a mouse mesenteric artery. The mesentery is a good tissue bed for practice, as there are many vessels of different sizes, so you can challenge yourself by trying to isolate a smaller diameter vessel. You should pin out the vessels in a vertical orientation to help with tissue isolation and cleaning. Start by removing the connective tissue on each side. You will then need to remove the top layer of connective tissue above the vessels so you can determine which vessel is the artery and which is the vein. The artery will appear more white as it will have thicker walls. The vein will appear more red or darker as they have very thin walls. Under high magnification, you can actually see the thickness of the walls. You want to avoid grabbing or cutting the artery at all costs. You should always grab connective tissue and cut that away. If you are too rough in handling the vessel, you could damage the cells and they will be unresponsive to your agonists. You can now cut away the artery and move it to your tissue chamber. After you've dissected your vessel, you need to prepare the chamber in order for mounting. Start by filling the tissue chamber with your PSS. Make sure this is cold and certainly not warmed. You then need to fill the line of the tubing and the cannula. However, do keep an eye on the pressure that you are adding, as you can easily exert higher than 250 millimeters of mercury, which is where you can damage your pressure transducer. You can see the bubbles coming out, and once they stop coming from the cannula, you know you've filled that line. Close that three-way valve, and the chamber is now ready for mounting. To begin mounting your vessel, you will need 2 sutures on each mount, 2 on the glass cannula and 2 on the steel mounting pin. You will need to mount your vessel on the glass cannula first before mounting the second side. Try to only touch the vessel near the end, the area that will be behind the suture once it's mounted. Carefully slide your vessel up the glass cannula until you have space for 2 sutures. Loosen the knots on your sutures and move them in place, but be careful not to push your vessel off. Tighten each suture securely. After you have your first side mounted on the glass cannula, you will need to add a small bit of pressure in order to open the second side of your vessel and also push out any blood remaining in the artery. Be careful not to add too much pressure, as you can easily damage the pressure transducer. You are only trying to open the second end and expel the blood. Sometimes you will need to use your forceps to open the second end. Move the P1 cannula so that you have a small overlap between your vessel and the steel mounting pin. You can then loosen the first suture on the steel mounting pin, slide it over your vessel and the steel pin, and tighten securely. Repeat the same process with the second suture. You can add a small amount of pressure through the three-way valve and then close it to make sure that your vessel holds that shape. If you see the vessel come back to its resting position, you know that you have a leak in either your vessel or the sutures. The last mounting step is to cut the ends of the suture so that these long ends do not enter the viewing window during your experiment. After mounting, you will bring your chamber back to the microscope. You will reconnect the Myograph cable from the interface, the P1 tubing from the bottle to your chamber, and then you will need to fill your P1 bottle on your interface. Unscrew the cap and pour approximately 100 milliliters into the bottle. Reattach the cap on this bottle and tighten it securely. You will need to fill the P1 tubing coming from your bottle to the chamber. Connect your syringe with tubing and draw it up until you can see that the lines are now filled. You may then open the three-way valve. The system is now ready to start the experiment. You can turn on heat and you can turn on pressure. You will want to make sure that your pressure is set to something low, like 10 millimeters of mercury to start. When you are ready to start your experiment in Myoview, you need to do three things. You need to turn on the camera so you can see your vessel. You will start the heater and you will also begin to pressurize your vessel. Click Capture under Camera and you can see your vessel. Now you will want to optimize this image so you can see through your vessel and track the vessel walls. You may need to adjust the focal plane as well as the camera settings in order to get the best image. The vessel will get easier to track once it's under pressure. You can draw your box over your vessel to begin tracking the walls. However, the software will have a hard time picking it up until the vessel is pressurized. Turn on the heater, and you can also turn on your pressure. Make sure that your P1 is set to something small, like 10 millimeters of mercury. You can start recording in Myoview even if your settings are not perfect. You will have a long waiting period for the vessel to warm up. You can adjust the brightness, gamma, and gain as well as the light level in order to get the optimal contrast between the walls and the background. You can right-click in the trace window to select the data parameter that you would like to view. We will select inner diameter. You may need to adjust the y-axis in order to view your data. You can see on the box to the right, the inner diameter is 203. So we will need to adjust the y-axis until we see 203. We will now perform our pressure steps, increasing the pressure in the system by 20 millimeters of mercury for each step. Once we reach 100, we will stretch and make sure that our vessel is properly stretched under the proper longitudinal tension. Then we will drop to the mean arterial pressure of 60 millimeters of mercury. You can provide a little stretch to help straighten out the vessel after you increase the pressures. We will now go to 50 millimeters of mercury. We will now increase to 70 millimeters of mercury. We can now go to 90 millimeters of mercury. You can see the vessels moving. So we will add some stretch to help straighten that out. We can then reach 100. Now that the vessel is pressurized to 100 millimeters of mercury, this is where we will do our final stretch. Stretch the vessel until it is perfectly straight. Now that it's properly stretched at 100, we can drop down to 60 millimeters of mercury. We're going to now show a small contractile response to a high potassium PSS buffer. This response will help show the function of the smooth muscle cells and is easily washed out. We will add a comment that we are about to add to KPSS. So we will add the comment, and then we will remove all of the previous buffer that was in there. We will let this exposure go for 3 minutes and then do 3 washes with normal PSS. We can now do 3 washes with normal PSS. We will start by removing the high potassium PSS. And refill with warmed PSS. We can now add our phenylephrine in order to get a contractile response. We will add our comment, click enter, and add the drug. It will take some time to mix. We see a nice and sustained contraction to PSS. We will now add acetylcholine to show the relaxation of the same vessel. This concludes the experiment portion of this video. We wanted to show a contraction to our high potassium PSS, a contraction to phenylephrine, and a relaxation to acetylcholine. This is not a full experiment, just to show responses to contractile and relaxation agonists. For more information on the 114P blind sac system, please refer to the user manual on the DMT website or additional resource videos.